Okay, this is about the GCF, the greatest common factor. Now, the GCF of two numbers, x and y, is denoted by GCF x comma y. GCF is the greatest number which is a factor of given numbers. It's a factor of the given numbers. The GCF of two, if the GCF of two numbers is 1, then these numbers are called relatively prime. So now we are going to see how to calculate the GCF of two numbers and even three numbers. Depending on the complexity, there are two methods, okay? Simply picking up the factors and choosing the greatest factor for both, and the other is the prime factorizing method to find the GCF. This is for complicated numbers or bigger numbers. Now here it says find the GCF of 24 and 36. Now simply, now we list out the factors of 24. Now the factors of 24 include 1 is actually a common factor, okay? 2, 3, 4, 6, 8, 12, and 24 by itself. These are the factors of 24. And the factors of 36. The factors of 36 include again 2, 3, 4, 6, and 9, 12, 18, then 36. These are the factors of 36. Now here we have common factors. 2 is a common factor, 3 is also a common factor, 4 is also a common factor, 6 is also a common factor, and 12 is a common factor. There are no more common factors. So of the common factors we have, here we have the common factors. Of the common factors we have for 24 and 36, 12 is the bigger one, the greatest one. So that the GCF of the greatest common factor of 24 and 36 is simply 12. Simply 12. Now, some more example. Okay. What is the GCF of let's say 250? Well, 250 is big. 45 and 72. Now again, we have to list out the factors of 45 and the factors of 72. The factors of 45 include, 45, now 3, 5, 9, 15, and 45. 3, 5, 9, 45. Okay, the factors of 72 include 2, 3, 4, 6, 8, 9, 12, perhaps 24, 36, then 72. Now these are the factors of 72. Now here we have the common factors. 3 is a common factor, and 9 is a common factor, and there are no common factors. Okay, we do have common factors. Okay. So from this, it's easy. It's easy to say that 9 is the GCF of, okay? 9 is now GCF of 45 and 72 is equal to 9. The greatest factor of 45 and 72 is 9. This is somehow lengthy method of calculating the GCF of numbers in cases where we have bigger numbers or numbers which are more than 2. If we are supposed to find the GCF of 3 numbers, we have to list out all the factors of the 3, and we have to check the common and find the GCF. But for this let's say complicated way, or just to shorten it, we do have another method. This is a common method. We do have the prime factorization method of the prime factorizing method to find the GCF. Now the prime factorizing method has 2 steps which are simple and fast to solve. This is the other method, the most effective, fast method to solve or to find the GCF. Now here in the prime factorizing method to find the GCF, the first step is prime factorization of each number, whether it's 2 or 3 number. Now the second step is form the GCF of the numbers as a product of every factor, that appears in the prime factorization of all or both the numbers with the least times or with the least power. Okay, with the least times or with the least power. Okay. Now using this method, we can solve or we can calculate the GCF of big numbers or the GCF of different numbers. For instance, okay, as an example, okay, find the GCF of 64 and a third. 64 and a third. Now here, the first step is prime factorization of each number. Now, here we have 64, here we have a third. So, now by 2, 32, by 2, 16, by 2, 8, by 2, 4. Okay, this is the prime factorization of 64. Now, the prime factorization of 80 is by 240, by 220, by 210, by 25, by 51, by 51. Now, from the prime factorization, 64 is equivalent to, this is equal to 1, 2, 3, 4, 5, 6 to the power of 6. And this is equal to, now, to the power of 1, 2, 3, 4, to the power of 4 times 5. So what are the common numbers? The common numbers, which are the factors, the factors of 64 and a third. 2 is the common. 2 is the common one. So here we have 64. This is equal to the power of 6 times, let's say, 1, and a third, which is equal to the power of 4 times 5. Times 5. Now form the GCF of the numbers as a product of every factor that appears in the prime factorization. Okay, in the prime factorization. Now here, 64 is to the power of 6 times 1. Now a t is to the power of 4 times 5. Now 2 happens, okay? 2 appears in both cases, in both 64. 2 happens in as a factor of 64 and a t. But in which case does the power of 2 is less is the biggest question. Now here the power of 2 is 6, so to the power of 6. Here in a t the power of 2 is 4, so to the power of 4. This is the least times or the least power. So the GCF of the two numbers, okay? GCF of 64, comma AT is equal to the power of 4. The greatest common factor of this is to the power of 4, which is equal to 16. 16. Okay? Using this method, it's possible to find the GCF of even higher numbers, bigger numbers. We do have the second example. Now find the GCF of 180, 450, and 800. Now in this method, the first step is prime factorization, then form the GCF of the numbers as a product of every factor that appears in the prime factorization of each, and take the least times or power. Now here, the prime factorization for each number is as follows. 180 now by 2, 90 by 2, 45 by 3, 15 by 3, 5 by 5, 1. And 450 by 2, this is 2, 2, 5 by 5, 4 times, 45, then by 3, 15 by 3, 5 by 5, 1. And 800, okay, can be factorized like this is 400, 200, again by 2, 100 times, by 2, 50, by 2, 25, then by 5, then by 5, 1. So every number can be written, okay? The factors of every number can be written as follows. Now this is a factorization of 800. Then 180 is equal to 2 times 2 the power of 2 times 3 the power of 2 times 5 the power of 1. 450 is equal to 2 the power of 1 times 3 the power of 2 times 5 the power of 2. And 800 is equal to 1, 2, 3, 4, 5 to the power of 5 times 5 the power of 2, 5 the power of 2. Good. So what are the numbers that appear as a factor of those three numbers? Now 2 appear, okay, in 3 of the numbers. 3 appears only on the 2, and 5 appears in 3 of the numbers. We are supposed to take the least times or the least power that happen in the prime factorization. So 2 happens here as 2 to the power of 2. 2 appears here as 2 to the power of 1, and 2 appears here as 2 to the power of 5. Now the least one is 2 the power of 1. Now 3 doesn't appear here, or in the other sense, 3 appears here as 3 the power of 0. It's possible because 3 the power of 0 is 1. So now we take GCF of 180, 450, 800 is equal to 2 is taken as 2 the power of 1. 2 the power of 1. Okay. The next is 5. Now 5 happens here as power of 2, and power of 1. Now this is the least one. Times 5 the power of 1. For convenience, in fact, 3 has happened in the case of 180 and 450, so that we can, for convenience, we can say that 3 has happened as 3 the power of 0 in 800, meaning this is 1, so that 3 the power of 0 can be taken as 1. So this product is 10. The GCF of 180, 450, and 800 is simply found to be 10 using the prime factorization method. I want to give you a more complicated or bigger number, okay? Now, example 3, find the GCF of 900, 1,500, and 7,200. It seems the sky has fallen on you, but it's very simple. The critical thing you have to do is factorizing the number, making the prime factorization very, very seriously, because that is a sensitive part, because choosing the least happened or the least factor is an easy one, so that you have to be careful in factorizing. I need you to stop this video, okay, to pause this video and calculate by your hand, and then continue to check the work. Now here, for to save time, I have factorized it in advance. So the factors of this number, the factors of 900 are, okay, 2 the power of 2, 2 the power of 2 times 3 the power of 2 and 5 the power of 2. 4, okay, 25 times 4 is 100. 100 times 9 is 900. Yes, right. The factors of 400, 4,000 or 1,500. The factors of 1,500 are okay. The factors of 1,500 is 2 the power of 2 times 3 the power of 1 times 5 the power of 3. Okay, 1,500. The factors of 7,200 are 2 the power of 5 times 3 the power of 2 times 5 the power of 2. For convenience, it's better to check. So 2 times 2 the power of 5 is 32, times 3 the power of 2 is 9, times this is 25. This is 7,200. And 2 the power of 2 is 4, times 3 times this is 125. This is 1,500. Good. So now what are the common factors? Now 2 is a common factor, okay? 2 the power of 2, 2 the power of 2, 2 the power of 5. 2 is the base, so that 2 is a common factor. And again, 3 is a common factor, and 5 is also the common factor. This is not 53. This is 5 to the power of 3. So, in which case does 2 happen with the less power or in least times? Now here we have 2 to the power of 2, 2 to the power of 2, 2 to the power of 5. This is a bigger one. Now 2 to the power of 2. So GCF of 900, 1500, 7200 is equal to. Now one of them is taken, 2 to the power of 2 times. Now of the 3's, here this is 3 to the power of 2, 3 to the power of 1 is least times, 1 times, 3 happened 1 time. So 3 to the power of 1 times. Now here we have 5 to the power of 2, 5 to the power of 2, 5 to the power of 3, and 5 to the power of 2. So this is a bigger one. Then now this is to mean one of the 5 to the power of 2's is taken as common, 5 to the power of 2. So what is the possible product of this? This is 4 times 25 is 100, 100 times 3 is 100 times 3 is 300. So now you see the GCF of 900, 1500, and 7200 is 300. Okay, now this is 300. Okay, this is 300. So the GCF, okay, GCF of these numbers 900, 1500, and 7200 is simply 300. Okay, this is the greatest common factor. So using this method, and by knowing how to find the LCM, it's possible to relate the numbers whose GCF and LCM are calculated. So my next video is on LCM, and this is a AHA tube. Okay, this is a AHA tube. Okay, AHA tube. I expect you to like and share to encourage me do more videos on maths, physics, and engineering. So stay with AHA tube. Thank you for watching.